Section 13.3, the unit circle. In your notes, you have a spot to write the I can statement down, so please write that down now. I can convert angle measures between degrees and radians and find the values of trig functions on the unit circle. Let's start with the warm-up. We're going to solve each triangle for all the missing sides and angles, write our answers in fraction form, and the angles below are in degrees. So these are two examples using special triangles. And this is going to be important because we're going to use special triangles today in deriving the coordinates in a unit circle. So we have a 45, 45, 90. The reason I know that is all of the angles have to add up to 180 in a triangle. In a 45, 45, 90, we know that the two legs of the triangle, I'm going to call them L, are equal to each other, and the hypotenuse is L root 2. Recall that our job is to start with what we know, which is the hypotenuse. And what I'm going to do is I'm going to set 1, which is hypotenuse, equal to L root 2, and I'm going to solve for L by dividing by root 2. So L is equal to 1 over root 2, but we don't ever leave the radical in our denominator. So what we're going to do is back to my pen here. Multiply the top and bottom by root 2. So that's the square root of 2 over 2. And so what we just found right now was L. So root 2 over 2 and root 2 over 2. And there's a reason that we're using 1 as the hypotenuse in both of these, and I'll explain that in a little while here. This other one is a 30, 60, 90. And on a 30, 60, 90, we know that the side opposite 30 is S. Side opposite the side opposite the 90 degree, which is the hypotenuse, is 2S. And this is S root 3. So again, we start with what we know and do that. Divide by 2. So S is equal to 1/2. So we can fill that in. And so therefore, the side opposite the 60 degree is going to be 1/2 times root 3, which is just going to be root 3 over 2. All right, so we found all the sides for each of these triangles. I'm going to scroll down. I wrote this ahead of time to save on time in the video. You might need to pause this because you should be writing this down in your notes. A unit circle is a circle with a radius of 1 unit. For an angle theta in standard position, remember we talked about that in the last section, standard position means the vertex is at 0, 0, and the initial side is on the positive side of the x-axis. In that case, cosine theta is always going to equal x, and sine theta is going to equal y. We know that tan theta is sine over cosine, so therefore tan will be y divided by x. Why we're talking in terms of x and y is because we're going to create each of the points on a unit circle, and we know that a point has an x and a y when we're graphing points. And what that means is your x is your cosine theta and your y is your sine theta when we're talking a unit circle. So up here, when I talk about the radius of 1 unit, that is the reason for us starting with a measure of 1 on the hypotenuse, because we're going to use these triangles to derive the coordinates on the unit circle. So placing the right triangle on the unit circle, it looks like this. This is an example of what it looks like. What I did here is each of these special triangles 30, 60, 90, 45, 45, 90, and then again 30, 60, 90, I created, because we're going to demonstrate that in the video, how we're going to use them to derive our coordinates. So basically what it's saying is, if the angle at the origin were 30 degrees, this is 30 degrees. If the angle at the origin were 30 degrees, what would the values of x and y be? Well, x is on the horizontal. So x would be root 3 over 2, and y would be 1/2. X is your left and right, left and right. I'd place this triangle right here, and y is up and down. Would look something, oops, that one's not going to let me move. Never mind on that. I'll show you on the next screen. And next one, if the angle at the origin were the 45 degrees, what would be the values of x and y? Well, again, x is root 2 over 2, and y is root 2 over 2. And if the angle at the origin were the 60 degrees, what would be the values of x and y? X is the horizontal, and y is the vertical. What we're going to do now is we are going to fill in all the ordered pairs on the unit circle. And I'm going to demonstrate that by using these special triangles. So, for example, like in the last screen, I'm going to go back a minute. If the angle at the origin were 30 degrees, so if the angle at the origin were 30 degrees, what would be the values of x and y? Well, this is going to derive the coordinates for the 30 degree. So I'm going to go like this and write an ordered pair. Your x would be over this way, which would be the square root of 3 over 2. And your y, you're going up 1/2. That's how we derive the coordinates. Now, the one thing I'm going to point out is when we're deriving the coordinates of a unit circle, I always like to derive this point, the 90 degrees, the 180 degrees, and the 270 degrees, because those are pretty basic, and here's why. We know that the radius of a unit circle is 1. So if we were going to drive the point at 0 degrees, that means that we're going to the right 1 and up 0. 90 degrees, we're going to the right 0 and up 1. 180 degrees, we're going to the left 1 and up 0. And 270 degrees, we're going to the right 0 and down 1. Why 1? It's because we talked about it. The radius is 1. And this is a circle, and the radius is your distance from your center of your circle to any point on the outside of that circle. All right, so now let's continue here. I'm going to move this yellow. Oops. Let's go like this, like this. Let's see. There we go. Move that out of the way. And now let's grab the 45, 45, 90. And again, it's going to show us, there we go. So to derive the coordinates of on the unit circle at 45 degrees, here we go. We're going to the right, root 2 over 2, and we're going up, root 2 over 2. I'm going to move this one out of the way and grab this one. Here we go. So again, to get the coordinates at 60 degrees, when our angle theta 60 degrees in standard position. We're going to the right 1/2, and we're going up square root of 3 over 2. All right, I'm going to get this out of the way. Whoops, that's not what I wanted. Okay. All right, put this down here. All right, so once we have all of the coordinates, I'm just checking them for quadrant number 1, then the other quadrants use the same combination of numbers, but you have to just change the signs on the x and or the y. Because we know in the first quadrant, x and y is positive. But in the second quadrant, your x is negative, your y is positive. So watch what happens. So 120 degrees now goes with this one. Instead of a positive 1/2, we're going to go to the left 1/2 and up. We're going to go to the left root 2 over 2 and up. And we're going to go to the left root 3 over 2 and up. Just checking all these. And we continue in the same manner. So at 210. So we're going to go, now both of them are negative, x and y, because we're going to go to the left root 3 over 2 and down 1/2. We're going to go to the left root 2 over 2 and down root 2 over 2. And I'm just going to make sure this, I want to make sure that that sticks out as a negative here. There we go. And on this one, we're going to go to the left 1/2 and down root 3 over 2. And the final quadrant, quadrant 4. Now x is positive and y is negative. So this is going to be 1/2 negative root 3 over 2. This is going to be root 2 over 2 negative root 2 over 2. And this is going to be root 3 over 2 negative 1/2. So take a minute to look at what I did here. But basically, once you get the first quadrant, the other quadrants come into play very easily just by knowing what the signs are on x and y in each of the quadrants. All right, in your notes, this screen, you don't have this extra unit circle, and that's fine. You filled it in right here. Now we're going to finish up this by answering the questions below. When we talk about circumference, we know that the circumference of a circle is 2 pi r. Well, if r is equal to 1, then the circumference is 2 pi times 1 is 2 pi. Circumference is the distance around the circle. So we're going from 0 to 300 if we travel all the way around to 360 degrees, or if we're talking radians, we're going from 0 all the way to 2 pi. So if we talk about what would half of a circle be, well, 1/2 of 2 pi over 1 is just pi. That's half of a circle. And if we talk about 1/4 of a circle, that's 1/4 times 2 pi, which is 2 pi over 4, which is pi over 2. And then 3/4 of a circle is 6 pi over 4, which is 3 pi over 2. We're going to label those values and then do the remaining values, which I did ahead of time. So like we said, 0, there's our starting point. If we go all the way around, we're going to end at 2 pi, which is the same thing as 12 pi over 6. So half of a circle, you'd go from 0, there's our pi. A fourth of a circle, we'd go from 0 to pi over 2, which is right here. And 3/4 of a circle, we go from 0 to 3 pi over 2. So here's what I want to point out, and then you can pause it and write these down. So on your screen, like I said, we've already written the coordinates, and which is there on that screen for me. And now we have degrees listed on a circle, unit circle. So a unit circle, you are talking in terms of degrees, or you can be talking in terms of radians. And so what I want to point out is this is as easy as knowing how to count. So if you look at my blue colors here, what I'm doing is I'm counting up by pi over 6, 1 pi over 6, 2 pi over 6, but that reduces to pi over 3, 3 pi over 6, which reduces to pi over 2. And I keep going. 4 pi over 6, and that reduces. 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. I skipped the green, as you can see, because the greens, which are at the 45 degrees, count up by pi over 4, 1 pi over 4. However, I want to point out the fourth of a circle, half of a circle, 3/4 of a circle get repeated when you're doing your counting. So 1 pi over 4. This is 2 pi over 4, 3 pi over 4. This is 4 pi over 4, 5 pi over 4, and this would be 6 pi over 4, 7 pi over 4, and this would be 8 pi over 4. That is how we come up with the radian degrees. So please write that down. And the one thing I want to point out is your job will be to write this down accurately, because then you will be able to use your accurately displayed unit circle when it comes time for the test. So it's very important that you take the time to write this down very, very carefully. Next, you're going to have to know how to change degrees to radians and radians to degrees. So if I give you an angle in degrees, all you're going to do is multiply that angle by pi divided by 180. Or if I give you an angle in radians, and I want you to tell me what that is equal to in degrees, you're going to take the radian angle and you're going to multiply it by 180 degrees divided by pi. It says pi radians because that's when you go from degrees to radians, it's going to be in radians. And here we're starting with radians. So if we're dividing by radians, the radians are going to cancel. That's the purpose. Let's do an example. So what we're going to do right now is we're going to do 2, 3, 6, and 7. And then I'm going to do 4, 5, 8, and 9 in class. So number 2. I'm going to start with my angle, which is in degree mode, and I'm going to convert from degrees to radians. So how to do that? You have to take your degree times pi divided by 180. So on your calculator, if you did that, the pi just stays pi, because that's the purpose. The pi stays because you're in radians. And if you take 30 divided by 160, you're going to get a fraction. That's a fraction. You're going to reduce that to get pi over 6. And number 3, I'm starting again in degrees. I'm going to take that times pi over 180. There's the pi. And if I reduce the fraction, negative 75 over 180, I get negative 5 over 12. Okay, let's do number 6. I start with 3 pi over 5. I'm now going from radians to degrees, so I have to multiply by 180 and divide by pi. So kind of notice what we're doing here. When we're going from degrees to radians, you're multiplying by pi divided by 180. And when you're going from radians to degrees, you're multiplying by 180 over pi. So we're just flipping it because look what happens. I said the pi's are going to cancel. And now we can take 3 times 180 divided by 5 on our calculator, and we're going to get 108 degrees. Number 7, negative 5 pi over 8. We're going to multiply that by 180 over pi. Pi's are going to cancel. We're going to take negative 5 times 180 divided by 8. We're going to get negative 112.5 degrees. All right. Now we're going to use the unit circle that we just made to find the exact value of each trigonometric function. So I'm going to do 10. I'm going to do 11 and 13 in class. So sine of 150 degrees. I'm going to go to my unit circle. 150 degrees is right there. X is cosine, Y is sine. So my answer is 1/2. 12. 12 is a little trickier because we know, I'm going to write what we know here. We know tan of theta, remember, we said is sine over cosine, which is taking your y divided by your x. So let's find tan of 11 pi over 6. And then we know that once we find tan of 11 pi over 6, then all we have to do is take the reciprocal of our answer to get cotan, because cotan is a reciprocal of tan. So let's go to our unit circle. 11 pi over 6. Okay? So 11 pi over 6 is right here. You'll have all this on one unit circle. I have it on 2 different screens. So 11 pi over 6 is at 330 degrees. And at 330 degrees, we have an x of root 3 over 2, and we have a y of negative 1/2. So let's go write that down. Okay. So if we know, we said that x is equal to root 3 over 2, and y is equal to negative 1/2. So let's do that. Take our y divided by our x. So take the top times the reciprocal of the bottom, negative 1 over root 3, but you can't, well, actually, we don't have to go any further because we're not trying to find tan. We're just trying to find cotan. And so all we have to do now is flip this. So put the root 3 on the top and the negative 1 on the bottom, which is really just negative root 3 on that. And again, we will do 11 and 13 in class. So now your homework is in your packet. You have problems numbers 19 to 30. Those are the problems that you're going to do.